topic 1.3, the division algorithm. Okay, so we have two cases in division algorithm. The first one is if m greater than 0. Okay, so we can write that m is equal to qn plus r, where qr is in integer, and the remainder is 0 in between 0 to n. 0 less than or equal to r, less than or equal to n. Okay, so before that, what is m, what is q, what is n, what is r? Okay, m stands for dividend, q stands for quotient, okay, n is a divisor, and r is a remainder. Okay, yeah? Remember, remainder should be between 0 to n. Okay, and the second case, if the dividend m is less than 0, which is dividend is negative, okay, so then r is equal to r plus n, and q is q minus 1. Okay, so let's see the example. Okay, oh, kat sini dah ada. It's okay. Okay, so given by q is equal to m div n. Okay. Okay, q is equal to m div n. Okay, memang div n. Okay. Okay, again q is a quotient, and r remainder is equal to m mod n, modulo, modulo. Okay, you have to memorize these two. Q is equal to m div n, and r is equal to m mod n. Okay, yang berbeza dia, the difference is here. Okay, okay, so let's see the example. So if r is equal to 0, so you can say that m is a multiple of n. Okay, so n divides m equal to qn. Okay, okay, for example here, m is a 12 and n is equal to 3. Okay, 12 is equal to 4 times 3 plus 0. M is we have a m is equal to qn plus r. You have to memorize. This is the division algorithm. Okay, what is the division algorithm? It is a m is equal to qn plus r. Okay, where r is 0 less than or equal to r less than or equal to n. You have to memorize this one. Okay. Right, so let's see the example. What are the quotients and remainder when 101 is divided by 11? Okay, 101. Okay, we want a quotient and remainder. Okay, so bear in your mind, this is not about the calculations in common mathematics, common calculations in mathematics. Okay, which is this is a question, this is a remainder. No, quotient, what we want is a quotient. Q is equal to m div n. How to get it? Okay, so we use m is equal to qn plus r. Okay, m is 101. Q, okay, ignore for time being. N is 11. So what should be here? 9, right? 9 times 11, 99 plus 2, so you got 101. So what is quotient? Okay, quotient is 9. So the answer is 9, 101, div 11. Okay, so that is the answer. Okay, how about the remainder from here? We don't want remainder is equal to 2. We don't want this one. This is not a common calculation. Okay, in this script, you have to give the answer. The remainder is equal to 101 mod 11. So what is R? R is 2 equal to 101 mod 11. Okay? Okay, so next, what are the questions I remember when negative 11 is divided by 3? So once your m is less than 0, okay, you have to be careful. Okay, so bear in your mind your r is always greater than or equal to 0, less than or equal to your n. So you have to choose the right quotient. So you will have the right remainder. Okay, so negative 11, what does it mean? Again, negative 11 divided by 3. What does it mean? But you have to choose the right quotient so that you get the right remainder. Okay, see here. What should I put here as the quotient? Is it 3? Is it 3? No, you have to put negative 4. Really? Why you have to put negative 4? So 3 times negative 4, negative 12. So minus here, right? So negative 11 minus negative 12, negative 11 plus 12, you got 1. So your remainder should be greater than or equal to 0, less than or equal to your n. What is your n? Your n is 3. So is 1 in between 0 and 3? Yeah. So this is the right remainder. Okay, if you choose the wrong questions, then it leads to the wrong remainder for sure. For example, if you choose, let's say you choose negative 3, right? So then tends to choose negative 3 because they don't understand about this concept. Okay, so negative 9, so negative 11 plus 9, you got negative 2, but then negative 2 is not lying within a 0 to 3. Okay, this is completely wrong. So what is the quotient? Quotient is negative 4 equal to negative 11 div 3, and the remainder is 1 equal to negative 1 div mod 3, sorry. So find the quotient and remainder when m is equal to 17 and 13. So this one, I want you to try to do it on your own. Okay? All right. So this is the exercise. Okay, this one you have to try to do it. Believe me, if you don't try to do it, then you don't understand whether you understand it or not. Okay? All right, so the greatest common divisor, GCD. Okay? Actually, this one you dah belajar dekat your secondary school SD. Okay? Dan the answer punya terbesar divisor. Okay, so or we short it as a GCD. Okay, let's see the definition of GCD. If A, B, and K are in positive integer, and K divides A, and also K divides B, we can say that K is a common divisor of integer A and B. Okay, so if D is the largest such common divisor, K, so D is called the greatest common divisor such that D is equal to GCD, greatest common divisor, integer A, B. Okay. So before we go more details about GCD, there are three methods of finding GCD. The first one is we list down one by one, okay, the possible common divisor of the integers. The second one is we use a prime factorization method, and the third one is Euclidean algorithm. So Euclidean algorithm is a very interesting method. You will see later. Okay, but let's see the first method, which is the list down. All right. So, example: find GCD, greatest common divisor of 105 and 30. Okay, so you have to list down all the possible possible divisors of 30, and also the possible divisors of 105. So the divisors of 30 are 1, 2, 3, 5, 6, 15, 10, and also 30. And the possible divisors of 105 is 1, 3, 5, 7, 15, 21, 35, and 105, which is itself. So macam mana nak tahu how to know it? Actually, dia ada pair. Okay, 30 divided by 1, we got 30. Okay, we have a pair. You have to check, because some students, okay, do a careless mistake. Okay, so 30 divided by 1, you got 30. This is the pair of 1. Okay, 30 divided by 2, you got 15. 30 divided by 3, you got 10. And 30 divided by 5, you got 6 for sure. Okay, how about 105? Same, let's go to 105. Okay, 105 divided by 1, you got 105. And then 105 divided by 3, you got 35. 105 divided by 5, you got 31. And 105 divided by 7, you got 15. Okay, so let's see the common divisors of 30 and 105. Okay, the common divisors of 30 and 105 are 1, 3, 5, and also 15. But we are interested with the greatest common divisor of 105 and 30. Okay, so it is what is the greatest common divisor? It is 15. Okay, so GCD 105 30 is equal to 15. Okay, so let's see the question. Question asks you to find GCD 105 30. So please make sure that you leave the answer GCD 105 30. Don't leave the answer GCD 30 105. Don't. Please follow the originality of the question. 105 30, so equal to 15. Okay, that is the first method. So let's see another sample again. What is the greatest common divisor of 24 and 36? So you have to list down the possible divisors of 24 and 36 respectively. So the possible divisors of 24 is 1, 2, 3, 4, 6, 8. Okay, 12, and also 24. The divisors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and also it's 36. So therefore, the common divisors of 24 as well as 36 are 1, 2, 3, 4, 6, and 12. But what is the greatest common divisor, which is D of 24 and 36? Okay, equal to 12. Okay. All right. Okay, that is GCD. Okay. Using a list down method. So this is exercise again. Please do it for your better understanding. Okay. So we also have the second method, which is prime factorization. But before that, let's see relatively prime. Okay, relatively primes is when GCD AB is equal to 1. Okay, if we have GCD AB is equal to 1, so we say that okay, the integers are relatively prime. Okay, the integers. Okay, the integers are relatively prime. So what is the greatest common divisor of 19 and 22? So the solution is list down all the possible divisors of 19. So they are 1 and 19 is 7. How about 22? 1, 2, 11, and it's 7. Okay, so what is GCD 19 and 22? So 1, 1, so equal to 1. So we can say that, okay, the integers 19 and 22 are relatively prime. Okay. All right, so that's the idea. Now we move to the pairwise relatively prime. Okay, the keyword is pair. Pair maksudnya berdua, berpasangan. Okay, so this integer A1, A2, and AN are pairwise relatively prime if GCD A, I, B, J is equal to 1, wherever 1 less than or equal to I less than J less than or equal to N. Okay, so let's see the example. Determine whether the integers 10, 17, and 21 are pairwise relatively prime, and whether the integers 10, 19, and 24 are pairwise relatively prime. So let's see the integers of 10, 17, and 21 first. Okay, what are the possible divisors of 17, 10, and 21 respectively? So the divisors of 10 is 1, 2, 5, and also is 7. Okay, how about 17? 1 and 17. How about 21? 1, 3, 7, and 21. Okay, so what is the common divisor? Okay, if you see here 10 and 17, 1, 1, also 1. Okay, so you have to, for pairwise relatively prime, you have to check one by one because of pair. So GCD 10, 17. So follow this one. 10, 17 first, and then 10, 20 first, and then 10, 20, 21. Okay, so GCD 10, 17, 1, GCD, okay, 10, 21, 10, 21, also 1. Okay, how about GCD? Okay, 17, 21, also 1. Since all GCDs, okay, of a pair wise are relatively prime, so we can say that therefore, okay, the integers 10, 17, and 21 are relatively prime. Okay, so you memang kena check one by one, no choice. Okay, so determine whether the integer 10, 19, and 24 are pairwise relatively prime. So macam mana nak check? Okay, you have to check one by one. So 1 to 5, 10. Sorry, 1 to 5, 10. What is the okay divisors of 19? 1, 19. How about 24? 24 is 1, 2, 3, 4, 6. 8, 12, and etc. Okay, again, kalau you tak sure, okay, you kena try lah. 1 divided by 1, 24. Okay, 24 divided by 1, 24. Okay, 24 divided by 2, 12, 24 divided by 3, 8, 24 divided by 4, 6. Yeah. So like I said, you have to do one by one, no choice. GCD 10, 19. Okay. 1. GCD 10, 24. You have 1, 2. Okay, so 2. And then GCD 19, 24 equal to 1. All right, plus since we have GCD 10, 24 is equal to 2, which is not relatively prime, so we can say that the integers 10, 19, and 24 are not pairwise relatively prime. So that's why you have to choose. You have to check one by one. That is the reason. Okay, that is the reason why. Okay. All right. So this is exercise. You may try to do it. Now we move to the second method of finding GCD by prime factorization. Okay. So again, we have sequence of prime factorization. P stands for prime. Okay. This one is A. Okay. This one, I will give you the answer after that. I will give you the example after this for your better understanding. So given that GCD AB is given by this formula, GCD AB is equal to, okay, prime 1, okay, because of here is the greatest, so you will choose the minimum power. Okay, since this is the greatest, so you will choose the minimum power. Okay. All right, so let's see the example. What is the greatest common divisor of 120 and also 500? Okay, so you have to find what is the prime factorizations of 120. Again, tak tahu macam mana buat macam ni, 120. And you have to divide it by the smallest prime. Okay, so 120 divided by 2 lah, smallest. Okay, so you got 60, right? Okay, so lagi 60 can be divided by 2, can be divided by 3, can be divided by 5. But I say that use the smallest prime, so 2 again. 60 divided by 2, you got 30. Okay, divided by the smallest, okay, prime again, divided by 2, you got 15. Yeah, 15 divided by the smallest prime, so 15 can be divided by 3, can be divided by 5 as well, but the smallest is 3. Okay, 15 divided by 3, you got 5, so 5, no choice, 5, you got 1, betul. So 2 times 2, 4 times 2, 8 times 3, 24 times 5, yes, 120. So what is the prime factorizations of 120? It is 2, 1, 2, 3. 2 cube times 3 times 5. Okay, so how about 500? 500 same. Okay, you do this 500 divided by the smallest. What is the smallest prime that can be divided by 500? 2 smallest. 500 can be divided by 2, can be divided by 5. But the smallest prime, 2. Okay, so 250. Again, choose the smallest prime 2 as well. So you got 125. So 2 cannot 2 lah because of 5 here. So 5 here. Okay, you got what here? 25. Okay, 25 divided by 5. Got 5. So 5 here. And then you got 1. Okay. So here you have 2 square. And also 5 cube. Okay. Alright, so now we want to find GCD 120 and 500. So, right, by using a prime factorization method, so GCD 120 and 500 is equal to 2, okay, greatest power, you will choose a minimum power, okay, 2, power here should be 3, 2. Times 3 minimum, okay, okay, here, this one you need an explanation. Here is A, here is B, because of we have GCD, AB, so here is A, here is power for B, okay, so 3 mean, okay, power of 3, power of 1 here. How about B? How about B? We have no 3 here. But because of 3, power of 0 is 1. So you still got the same answer. Okay, and then you have 5. Minimum, okay, for A, okay, 5. For, sorry. Power, okay, power. Okay, 5 power of 1. And also here, 3. Okay. All right, so we chose, okay, the minimum power. 2, minimum 3 and 2, what is the minimum? 2. Okay, for 3, minimum 1 and 0, what is minimum? 0. Okay, how about 5? Minimum is 1. So we have 2 squared times 5. 2 squared is 4 times 5. Okay, 20. So 20 is the answer. Okay. All right. Okay.